this one in, we get y equals a negative 10.07, and then it says x squared, and then 51.41, and then x, and then plus 11. Now if we type this into our y equals, just this into our y equals, are any of our answers going to be correct? No, we can't type in the rounded decimal. Okay? All right. So now here we need to use the equation above to determine the height of the ball at 2.5 seconds. Did I give you x or did I give you y? How do you know? Yeah. And time is x, height is y. So I gave you x equals 2.5. So then we talked about how do we get that into our calculator. So we go second trace value 2.5, enter. Now I actually got an answer. This window is all wonky. Why is this window all wonky? Because I didn't actually change my window, right? So I go to my window and I make sure that I go from 0, which is time, 0 to, let's say 10, and then 0 to a height of 74, so I'm going to go higher than that. I'm going to go 100. And I have my graph. So yeah, so I go second trace value 2.5, and it gives me 76.575. And then I go back here and it says meters. So at 2.5 seconds, I'm at 76.575 meters. And then I do my 4.5. Second trace value 4.5, and I get 38.39. Then here it wants to know, when does the ball hit the ground? When we hear hit the ground, what's it asking us for?
0.
Height is 0. So it's asking me, what is height? Height is 0, so I could either go y equals 0 and find out where they intersect, or it's asking me to find the what? What's it asking me to find? The x-intercept. When it hits the ground, it's just the x-intercept, correct? So how do I find x-intercepts? I can go second trace value, or second trace number 2, which is 0s, because 0s, roots, and x-intercepts are the same thing. Now it says left bound, so I need to be on the left side of the x-intercept, which I currently am, so I hit enter. Then it says right bound. Now I need to go below the x-axis so that I'm on the right side somewhere. Enter. I picked a left, I picked a right, and then I hit enter for guess. And I get 5.31. So if I did my little sketch of this graph, it starts here and it goes down like that, right? So I have a graph like this. I know currently that this is 5.31. Now why am I writing these down here? Because these will help me with my domain and range, right? If I write those like main points, where does time start? Yeah, 0 seconds. We agree?
Yeah.
So if I have those two things, I can immediately come down here and do my domain. So I'd say x such that, well, my domain starts at 0, because that's the time. And then I do loser, loser, slanted else, low to high. And this is 5.31 XER. Now, could I find more x's on that actual graph? Yes. But in the context of the question, can I find more x's? No, at 5.31, the ball hits the ground. Does it keep doing anything after 5.31? No, it hit the ground. Ball's done. Just like that. Just wanted to show you it doesn't keep moving. See, it stops. All right. Yes. So here it says, what time does the ball reach a height of 60 meters? So what did they give me? X or Y? Y. No one should be on their phones. So this is y equals 60. So do I put that into my y1 and just clear out my equation that's there already? No, that would be stupid. So it's going to be 60 here. And then I press graph. What do we do? Then we need to find out where they do what? Intersect. So I go second, trace 5. Enter, enter, enter. This one happens to have 2 spots where it reaches 60, which makes sense. It starts below 60, it goes through 60, reaches a maximum, and then comes back down through 60. So you can get 2 answers. So I get 1.27. And then I have another one. Second, trace 5. And I go enter, enter, enter. And I get 3.84. Now here it wants to know what is the maximum height, and then here what time does it reach the maximum height. I still find those the same with my calculator, because when it says the word maximum, I have to find the maximum, correct? One of them is just the x, and one of them is just the y. So if I'm asking for what is the maximum height, that's the y of the maximum. We agree? Because height is y. If it asks for what time does it reach the maximum height, that's the x of the maximum. So once I find the actual coordinate of the maximum, I have 2 answers. So I'm going to go second, trace, maximum, which is 4. And then I do left bound, enter, right bound, enter, enter. So it's 2.55 and 76.70. 2.55, that is not a 5. 2.55 and 76.60. So that is my actual maximum coordinate. Which one of those numbers represents the maximum height? The y, right? This is time, because x is time, and this is height. And this is max, correct? So here it says, what is the maximum height? Well, it's 76.60, because y is always max height. And then what time does it reach the maximum height? 2.55 seconds. This one says, what is the height of the ball at the moment of release? What is moment of release a fancy way of saying?
0 seconds.
That time is 0, right? Moment of release is, I haven't started. Now it starts. Like the moment I let go of it, time starts. This would be 0. So moment of release, what is this? I love this computer with random things that I don't even put on it. That we can't take off. So t equals 0 seconds. So they accidentally hit this thing that pops up and that gives me all this knowledge of news that I don't care about. It also tells me when like the NASDAQ is going up. Does I care? I don't.
No, I didn't.
And then it's mostly cloudy out. And I just realized it's in Fahrenheit. So that's like mathematics. You guys can convert it to Celsius. Okay. So I know x if it's time. So I go second, trace, value, x equals 0, enter, and it's at 11. Do you see that? So it's at 11 meters. So the height at the moment of release is 11 meters. So what do you suppose that 11 meters is? This right here is 11. Let me repeat the question. Josie hit a golf ball from the top of a hill. The height of the ball above the green is given in the table below. What do you suppose that 11 counts for? The height of the hill and maybe a little bit of a tee, if they're using a tee on for the golf ball, right? If there's no tee, it just says they're hitting the golf ball off the top of the hill. Well, that 11 represents the hill height, right? So if I go to do my range, though, some people will tell me it's from 11, and this is 76.6. They'll say it's from 11 to 76.6. Remember, I have to represent every y that could exist. So what's my lowest y that can exist for height?
11.
Nope.
0.
0, because it can go to the ground, can't it? So what's my lowest y? 0 to 76.6. And what's my x, which is time? 0 to 5.31. Right? So, my range is going to be from 0 to 76.60. And why did we keep going? The ball hit the ground. It was done. It is completed. It is over. Okay, we're flipping over to polynomial equations given. So this whole lesson that we did, we had to get the regression from data, correct? I gave you data, and then I had to say linear, quadratic, or cubic, and you had to give me the regression. Okay? But, and people freak out about these ones, but remember I told you the window's easy to make because it's below the lowest x and above the highest x and below the lowest y and above the highest y. These ones people struggle with a bit more because we don't have to get the equation, they give it to us, but we don't have a table to help us with the windows. And windows are usually people's little panic attacks. So we're going to talk about this. So let's look through here. Polynomial equations given. It said, if it asks for the instant something's happening, it's asking for the y-intercept. So if it asks for the instant something is happening, it's asking for the y-intercept. If it asks for a height at time 0, it's asking for the y-intercept. And the other thing was that this also happens is, remember that one just said moment of release. Moment of release was time 0 as well. Okay. If it asks for the maximum or minimum height, they're asking you for the y of the maximum or minimum. If it asks you for time to reach max or min, they're asking you for the x of the max minimum. Ask for when the object hits the ground. They're asking you for the x-intercept. If it gives you a specific y and asks you to find the specific x, you put it into y2 and determine the x value of the intersection. If it gives you a specific x and asks for a specific y, then you use second trace value x equals, and then you put that value in and find out what the y is. Now here it says, remember, domain and range are restricted in word problems as you cannot have negative time or negative length. Always make sure you only list values that make sense in the context of the question, right? So polynomials, linear, quadratic, and cubic, have domains of XER, every single one of them, unless it's a word problem. Then it could be restricted. Okay, so here we have the growth of a tree can be modeled by this function. Is this linear, quadratic, or cubic? It's linear because it's t to the 1, correct? So I know this is a linear. I know that this is a degree 1. I know it's an odd degree. Do you guys remember about these? The constant at the back is just the what? What is the constant at the back of an equation? The y-intercept. So I know that my y-intercept is at negative 0.45. Very tiny, correct? What does the leading coefficient tell me? Do you remember? Sign of the leading coefficient, this one is positive. What does it tell me? Yeah, ends up on the right. So that's all I really know about this. So here it says the growth of a tree can be modeled by the function 2.3t minus 0.45. Why would the growth of a tree start at negative 0.45 where height is in meters and t is in time in years? Why would the height of a tree start negative? It's a seed in the ground. And what's the ground level height? Ground level?
No, 0.
0. So it's just a seed in the ground. Do we see? So it makes sense. It should make sense. It's a real life problem. So here it says, to the nearest tenth of a year, approximately how long will it take the tree to grow to 32 meters tall? If you need to, this is what I do every single time when I get one of these questions. Do you see T? Where is T in X or Y spot? X. So I say T equals X to help myself out. And T is in years. So it's time in years. And then I label my other thing. What is this? Where's H of T? H of T is in what spot? Normally where Y is. And what is Y in? Y is height in what? Height in what? Says it in the question.
Meters.
Meters. Now, why would I do that? Because that will help me determine, did they give me X or did they give me Y? Let's read the question again. To the nearest tenth of a year, approximately how long will it take the tree to grow to 32 meters tall? Did they give me X or did they give me Y? 32 meters tall. T is time in years, which represents X. H of T is Y, which is height in meters. Did they give me X or did they give me Y? Guys, just match the units. They gave me Y. It's 32 meters. It's height. Is it not? So it's Y. I really hope your quietness just meant you knew it. There was 2 people who answered. I wanted to see if everyone else agreed. All right, cool. We can type in Y equals 32 into our Y2 and find out where they intersect, except we don't actually have an equation in your calculator, so that's useless. What do we first have to do? Put the H of T into the Y spot of your calculator. Okay. So we're going to go 2.3x minus 0.45. Once again, I repeat, no one is using your calculator but you on a test. I am not using your calculator. So if you are not typing this in right now, it is not helpful to you. So now I press graph. But I did absolutely nothing to the window. So let's make some educated decisions here. This is talking about a tree, correct? Height in meters. Now here it says, we know that it starts negative. So if I go to my height, which is my Y, I know I could do like negative 10. And a tree, they're talking about 32 meters tall. So I need to be taller than that. So maybe I make it 50. Because height is Y. And I get that information from this question, right? It gives me information. We don't just wing a table or wing a window. Now, X is time in years. What can we start at for time in years? What does a tree start at? 0. Planted. There we go. Starts at 0. Now, we don't know how many years to go to. However, this is a multiple choice question. Do you see the answers in the multiple choice? 13.7, 14.1, 73.2, 74.1. So maybe what should I make my X max be?
75.
Bigger than that. 75? Sure. Bigger than the answers, right? I have to be able to at least have all the answers on there. And then I press graph. Now, we just discussed and said that Y is 32 because Y is the height. They gave us the height, correct? And if they give us the height, how do we do it? So we go to our calculator and we go to Y2 and we put in 32. And then we press what? Graph. If we can see where they intersect, we can calculate it, correct? If for some reason we press graph and we can't see where they intersect, there's no point in trying to find out where they intersect because unless you can see it, you can't calculate it. Okay? So now we go second, trace, what? Which one do we pick? 5. Intersect. And then enter, enter, enter. And where is it at? 14.1 what?
Meters. Years.
Years. Because it's x. So that's one question that they've given before on a diploma. Here are alternate versions of what they could have asked for this exact same question. Same data, they could ask alternate questions. What could they be? What was the original height of the tree? What was the original height of the tree? Negative 0.45 meters. Because original height just means times 0. Now they could have done this. Determine the height of the tree in 23 years. So now they want the height, which is x or y. Look at your equation. Its height is in h of t spots, that's y. They want y, the height of the tree in 23 years. What did they give us? An x. They gave us time, which is x, which is 23 years. Where can we put an x to input an x to get out a y? What are the buttons we press to input an x to get out a y? Second trace value. Second trace value, and it's 23. Now, if at any point in time you get an error, it's because your window actually can't do that. So like, if you're going second trace value 23, but your x max is 20, can it find 23? No. So often when you have an error, your window isn't big enough. So does that mean make it now be 1,000? No. Make it a little bigger. Make it bigger than what you're looking for. So I know if I'm looking for x equals 23, I know my x max has to at least be that. So I get 52.45 meters. Okay? Then we're going to flip over. So this is another diploma question I stole. And by stole, I mean used, because they have some released ones. Yeah. So this is another one that I took. Let's read it, and then let's decipher what the heck it's giving us. So remember, this one actually gives us an equation, so we don't have to find one. But we're going to go through it. A science class is investigation trajectories. It should be is investigating trajectories by launching balls for catapult. That would be fun. Put a ball in a catapult, let it launch. The pathway of one of the particular balls can be modeled by the quadratic function h equals negative 4.9t squared plus 7t plus 0.5, where h is the height of the ball above the ground in meters and t is the time elapsed since the launch in seconds. Okay, well, let's discuss this. So, which one of those is t or h my x? Is t or h my x? T, because it's here, and that's where all the x's will be found, correct? So t equals x, which equals time in seconds since launch. And then what does h represent? Y, because then where y would be. H equals y, which is the height of the ball above the ground in meters. Want to know what's cool?
What?
It's the last lesson in polynomials. So the next few days are just going to be review. Give you questions, see if you can do them. Give you questions, see if you can do them. Okay? Because your test is next week. So, your assignment for polynomials will be due on Monday. I'll try and release it tomorrow.
There's no OB book for this, right?
Just the assignment that I'm going to give you tomorrow. Okay, so what is this? Is this a linear, a quadratic, or a cubic? It's a quadratic because it is a degree what?
2.
2. Large 6 ones is a 2. So it's a quadratic. Which is a degree 2. Okay, now normally we can know two things from our equation when it's in standard form like this. What does the 0.5 represent?
Y-intercept.
This is my y-intercept. So in this actual situation, what could that represent? In this actual context. It's 0.5 meters. That's my y-intercept. What does it represent in this context? Starting height of the catapult, probably, right? Catapult's probably 0.5 meters tall. Yeah. Yeah. So the catapult's probably 0.5 meters tall. And this thing is concave up. Or, sorry, concave down. It's down on the right. And because it's degree 2, it's down on left. So we have some sort of graph that looks like this. We agree? Why didn't I draw this way, to the left? Because that's negative time, correct? Why didn't I draw down here to the right? Negative height. That catapult isn't going into like a swimming pool, right? You're not putting the ball in the swimming pool, it hits the ground, it stops. We agree? So we want the domain and range from here. So I need to find out what's my lowest y to my highest y. And then I need to find out what's my lowest x to my highest x. So you guys try and figure that out. Is it A, B, C, or D? Go. Using your calculator. Typing it in. So, let's get it to show up on our calculator. So first off, we have to type it in. It always makes me laugh. People call me over and they're like, Mrs. Lepp, I just can't, it just won't show up. And I'm like, press your y equals. And they press their y equals and it's completely empty. And I was like, what's showing up? And they're like, oh yeah, equation. But it's so funny. Like, you'll adjust your windows to every window you could possibly come up with, but you forget to put the equation in y equals. So to make sure that we have our y equals, remember every single time we start a new question, clear out what we had in there, right? So that we don't accidentally use the previous question. And you can understand that that's a possibility, right? It'd be very easy to just accidentally use the equation from the previous one, right? Okay, so we have negative 4.9 t squared plus 7t, and then plus 0.5. And if I just am stuck, I could always go 0, 10, 0, and 10 and see if anything, oopsies, 0 and 10 and see if something shows up. Because I know that 0.5 is the y-intercept. So I'm a little large here for both of these. So maybe I go 5 and 5. That's a little better. I could spread it out further, couldn't I? I could do, like this baby's landing pretty quick, isn't it? So if I want to find the maximum for my y, I do second trace maximum, which is number 4. Left bound. Enter, right bound. Enter, enter. So its maximum, is that 0.71 or 3? Is the maximum 0.71 or 3?
3.
It's 3. Maximum height is 3. Height is y, correct? So this one maxes out at 3. And it starts at 0. So it's not this one or this one. It's going to be 0 to 3, correct? So we've narrowed it down to A or C. And then I need my x. So you second trace number 2, which is 0. Because I want the x-intercept. Enter. Left bound, and then below, enter, enter, and I get 1.5. So it's C, right? Because this gets me 1.5 here. This gets me 3 here. So it's from 0 to 3, and then 0 to 1.5. Right? We just need to find our main points. Using this, I want you to give me these answers. Determine the height when the moment the ball was released. Determine the maximum height. Determine the time it reached maximum height. Determine the time the ball hit the ground. Determine the height of the ball at 0.5 seconds. Determine the second time the ball hits 1.2. Determine the time the ball was above a height of 0.75. Any of these can be asked off of that equation. So, start answering. So, we only have a couple minutes here. So, moment of release. The moment the ball was released, what are they asking for? T equals 0 seconds. Moment of release, nothing has happened. So they're asking for the y-intercept, right? What was the y-intercept? 0.5. I didn't have to type anything in my calculator. It's that constant. So 0.5 meters. Determine the max height. We found that already. What was the max height? 3 meters. At what time did it reach the maximum height? Second trace, 4, left bound, enter, right bound, enter, enter. 0.71 somethings. Seconds? I don't remember. Minutes or seconds? Should be seconds. Yeah. Determine the time of the ball hit the ground. 1.5 seconds. We already found that. Determine the height at 5 seconds. Well, that's time. So x equals 0.5. Well, t equals x. So we go second trace value, 0.5. And you get 2.775 meters. Determine the second time the ball reaches 1.2 meters. Well, that's your y2. And they want the second time. There's 2, so I have to get the second one. Second trace 5. Guys, can you stop packing up? Enter, enter, enter. And I get 1.32 seconds. This is the one that stumped people most, so please pay attention. It wants to know the time the ball was above 0.75 meters. So I put that into my y2. And I need to find the 2 intersections and subtract them. So I go 0.75. I press graph. And I need to know this time. So I need to know this time here, and then I can find the time between, correct? So if I find the second time, I just have to subtract the first time from it. So second trace, 5. Enter, enter, enter. And I get 139,19166. So I get that. And then I go second trace 5. And I get that. And then I can just subtract them. And I get 1.36.